everyone! So today we'll be working on the solution for week 6, Readability. So do note that this is the week 6 problem set. So if you're working on week 1's problem set for Readability, please watch my other video that's linked in the description below. So this problem set, we're actually looking to implement a program that will advise the appropriate grade level needed to comprehend some text. So this means that the user will be prompted to key in some text, and the output will be the corresponding grade level. So this will be done through the use of the Coleman-Liau index, where the formula is index equals to 0.0588 times L minus 0.296 times S minus 15.8, where L is the average number of letters per 100 words, and where S is the average number of sentences per 100 words. So for example, the user will be prompted to key in an input, which would be a few sentences of text, and the system will then let you know which grade level this corresponds with. So let's first look at the parameters and considerations that we have. So the program needs to count the number of letters, words, and sentences in the text key in, and it's helpful that they've determined some parameters. So for example, letters will include any lowercase or uppercase letter, and words will be defined as any sequence of characters separated by spaces, and sentences will be defined as a sequence of characters separated by a period, which is a full stop, exclamation point, or question mark. So what will be the structure of the code? So firstly, we'll prompt the user for the input. Next, we will count the number of letters, words, and sentences in the text, followed by applying the formula for the Coleman-Liau index to determine the corresponding grade level. So for the first step, we just need to prompt the user to key in the text, and we've done this in the previous exercises for week 6, so I won't cover the breakdown for this here. Let's focus on the next step instead, which is to count the number of letters in the text. So for this, it will include any uppercase or lowercase letters, and does not include any punctuation, digits, or other symbols. So in C, what we did was that we looked through each character in the text and counted a character as a letter, as long as it was between uppercase or lowercase A to Z. So what would this look like in Python? So we'll use the same concept of looping through each character in the text using the for loop. And for each character, we will use is alpha to check if it is an alphabet. If it is, we'll then add 1 to our letter count. So in Python, this is what it will look like. For I in text, as we look through each character in the text, and if I is alpha, then we will add 1 count to letters. Next, we'll count the number of words in the text, and this is counted as a sequence of letters separated by a space, and this is what we have in C. So to recap for this example that we have, notice that we will count 7 spaces for a sentence with 8 words. So when we write our formula to count the number of words in the text, it will be the number of spaces in total within the text plus 1, and this is actually to account for the last word in the text that does not have a space after it. So building on to what we worked on previously, for this in Python, it will be else if I equals to space, we'll add 1 count to words. Lastly, we'll count the number of sentences in the text, and this is represented as a sequence of characters that end with a full stop, exclamation point, or question mark. So this means that the total number of sentences in the text will be the total number of full stops, exclamation points, and question marks. So this is actually what we got in C, and this is what it will look like in Python, where we'll put else if I equals to full stop, exclamation point, or question mark. We will add 1 to the total sentences count that we have. So let's put this together in our program. So we'll first start by saying we will need to import from the CS50 library getString. Then we will prompt the user for the input. So we'll say getString, and we'll prompt the user to key in text. So next, what we're going to do is that we're going to declare our variables. Letters will be 0, words will start with 1 as we discussed earlier on, sentences equals to 0, and now let's start to count the number of letters, words, and sentences in a text. So for I in text, now we'll say if I is alpha, right, then we'll add 1 to our overall letters count. Else if I equals to a space, then we'll add 1 to our overall words count. And then else if it equals to a full stop, exclamation point, or question mark, then we'll add 1 to our overall sentence count. Okay, and that's pretty much what we need to do for this step. So if you found this video helpful so far, I would really appreciate it if you can subscribe to the channel and also like this video. This greatly helps to bump up this video up YouTube's algorithm and makes it more visible to others who are looking for similar problem sets. Next, now that we have the number of letters, words, and sentences, we can proceed to use the Coleman-Liau index to find the corresponding grade level. So L represents the average number of letters per 100 words, So this is actually done by taking letters divided by words times 100. And S is the average number of sentences per 100 words in a text. So to find S, it will be sentences divided by words times 100. And substituting L and S in the equation that we have, this is what we get. And let's wrap this up very quickly in our program. So moving on, now we'll start our new section, which is to find the corresponding grade level. So as mentioned, this is where the formula comes in. Letters divided by words times 100. And it will be sentence divided by words times 100. So now we need to tell the system when to print. So for example, they did mention if the corresponding index is less than 1, we will print before grade 1. Else, if the index is greater than or equals to 16, we will put grade 16 plus. And for all other cases, what we will simply do is that we will just print the corresponding grade level, where we will round it up to the closest integer. So let's compile this. So let me use some sample text that we have. Right, so that's grade 9. Let's try one more example. Oops, let's just retry it. Grade 10. One more example. Grade 16 plus. Right, and yep, there you go. So this is actually how you put this program that we previously did in C into Python, and that will be the solution for week 6 readability. So thank you so much for watching this video, and if you found it to be helpful, please remember to like and subscribe to the channel. This really helps with the videos, and I appreciate everyone who likes and comments on the video. This greatly helps with the visibility of the channel. Thank you, and I'll see you in the next upcoming videos.